Hi, my name is Mark Galley. I'm with Think Reliability, and this is a summary of a webinar I presented on October 13th, 2009, the important connection between root cause analysis and failure modes effects analysis. The topics I'm going to go over is a little bit about RCA, what is an FMEA, the distinction between did and could, and how these two tools, RCA and FMEA, connect, and a little bit about the benefits in improving your skills. There are a lot of different problem-solving tools, but fundamentally they're all based on the cause and effect principle. So by understanding cause and effect, it explains everything that goes well and goes poorly within your business. It also has to do with what happened in the past, what's going on now, and what's going on in the future. So the advantage of focusing on principle is that it gives you a consistent approach. Root cause analysis is a systematic method for identifying the causes of why a problem did happen, so you can prevent it from occurring. And failure modes effects analysis would be also a systematic approach for identifying and prioritizing the causes of how a problem could happen. So simple distinction is root cause analysis is typically in the past for something that did happen, and failure modes effects analysis is talking about the future where something could happen. One is thought of as being reactive, RCA, proactive, FMEA, but they fit together because of cause and effect. A couple concepts I think are important up front are this simple definition of risk is probability times consequence. You could take an incident that using a 1 to 10 scale has a probability of a 5, and on a 1 to 10 scale has a consequence of a 5. The number is a 25. Another incident could have a higher probability but a lower consequence, so it's a little bit lower in terms of the risk. Relative risk, and then incident C has a higher probability and a higher consequence, and it gives a number of 72. There's nothing special about the number 72 or 25. It's that it's a relative value that just says incident C has a higher risk than incident A or B, and maybe incident A is slightly higher. Again, the scale is subjective, but it's at least an indicator relative from relative one incident to the next. Another concept that's important that ties in with this idea of risk is this distinction between did and could. Anything in the past is a did, it did occur, and anything in the future is a could. The word could is also used for something that did not happen. It didn't actually occur in the past, but it could have. So what did happen is in the past. What could happen is either something that didn't occur in the past or something that has not yet occurred in the future. The reason this is important to cover is risk is probability times consequence. The probability that something did happen in the past once it has occurred is 100%. So there is no risk in the past. Risk is always in the future. Risk is in the things that have not happened yet but could happen, which is why it gets a probability number. Root cause analysis is a very common tool. Our cause mapping method takes an extremely fundamental approach that the weed is just a symptom. It's what's above the surface. It's what's obvious. What's beneath the surface, the root, it's what you need to dig into. You have to think of it as being a system, that when you have a weed in your business, you want to dig into the things that are not exactly obvious to prevent it from occurring. The word root in root cause analysis from our perspective just refers to what's beneath the surface. Root cause analysis is about digging into the details of an issue, not necessarily finding the root cause as a singular thing. In terms of how problems and processes relate, every problem is a signal that processes have broken down. Once you define the problem and conduct a cause and effect analysis and come up with solutions, those solutions end up being improvements in your process, the idea to prevent the problem from ever occurring. This is typically known as plan, do, check, act. The act piece being the investigation. You can investigate something that did happen, and you can investigate something that could happen. What did happen is in the past. It's called an incident, crisis, failure, defect, error, delay. What could happen is when people talk about near misses, potential, risk, issues in the future, failure modes, effects analysis, or process hazard analysis, anything to look at in the future. But this model of problems and processes, how they relate, fits that Schuhart cycle of plan, do, check, act. The did and the could are what we're going to focus on in this example. So in root cause analysis, when something did happen, you capture the impact of the goals, you lay out basic cause and effect relationships, and as you add detail, get much more specific, and then you identify different ways you could solve the problem in terms of possible solutions, and then you select the best solution. So simple problem analysis solutions for a root cause analysis. You start with the problem, that's the impact to the goals, and then you just ask why questions as you read across the page. It shows you how cause and effect pieces together, that everything that's a cause, when you ask why questions, can be viewed as an effect, and vice versa. They link together. It creates this chain of events. But a cause and effect relationship is fundamentally made up of an effect and a cause, and you need these two things. One is defined by the other. The effect is the result of a cause, and the cause is the producer of an effect. Every complex issue fundamentally breaks down into cause and effect relationships. So you could have an incident, just ask a few why questions. When you add more detail, you can zoom in and go from 3 causes or 3 why questions to 10. There are specific areas where you need to zoom in even more, add more detail, and you can go to another level of detail. This is just like a map, a scroll bar on a map that you're looking at on the internet, where you can zoom in or zoom out accordingly depending on how much detail you want. On the detailed map is where you're going to obviously add evidence and talk about possible solutions and identify those best ones. But this is really the concept of cause mapping, this ability to zoom in and zoom out, which is why we use the term map. A lot of root cause analysis methods are very heavy into the adjectives. A lot of terminology ends up maybe confusing what is fundamental cause and effect analysis, and we really try to simplify that approach, that a cause in the cause mapping method is the producer of an effect. You validate it with evidence. If you're missing evidence, it's called a possible cause, because you're not sure whether or not this cause actually occurred. The steps, again, are problem analysis, solution. In a root cause analysis, it's not just identifying the problem as a singular thing, it's identifying the impact to the goals. There might be 2 or 3 impacts to the goals. You could have a safety incident and a service issue and a labor issue all in one incident in terms of labor, in terms of cost. There isn't just a single problem, it's always defined by goals. There isn't a cause, there are causes, and you would dissect the issue accordingly. That's what analysis means. And then the solution step is where you identify the best solutions to mitigate the risk. So simple root cause analysis approach. The FMEA, the way that it ties in, this is the structure of the worksheet for a typical failure modes effects analysis. That you identify the item and the function. This could be a system or a component. You identify potential failure modes and then potential effects of those failure modes. The severity is really the consequence of this issue. The possible causes of this failure then can have probabilities put on them. It says occurrence or probability. And then current controls, what's in place in terms of us understanding or detecting that this has occurred, and there's a detection component here. Severity, occurrence, and detection is really consequence, probability, and this uncertainty, this ability to detect. When you do each of these on a 1 to 10 scale, it multiplies very nicely in an Excel file as an RPN number, which is just a risk priority number, and it just ranks which failure modes are of the highest risk. So when you're talking about something that could happen in the future, you can have probabilities on it, because some failure modes are more likely than others. Again, if it's in the past, if it did happen, there aren't any probabilities because it did occur. So you talk about risk and failure modes on things in the future, on how it could happen. It still fits this idea of, the act is the investigation, the solutions you come up with is the plan, you implement those, which is the do, those are part of your new work process, and then you check for results. Failure mode is a very simple term. It's like a mode of transportation. It's just a type of transportation. There are different ways to get from one place to another. You can walk or take a bicycle or a car or a plane. A mode of failure is just a type of failure. There are different ways a system can fail. So the example I used was the printer in your office. It could jam, or it could be out of paper, or it could be out of toner. Those are different ways the printer could fail, which are different failure modes. There are different ways that it could fail. So that's all a failure mode is a way of something can fail, or a type of failure. You could take the printer and say it's not functioning because it jammed, or you might find out maybe it's out of paper. We don't know yet what caused it to happen, or the toner cartridge is empty. These are different ways the printer could fail, and it would be useful as a troubleshooting guide. Notice they've got question marks because it means we don't know which one it is yet, and they're linked with or relationships, because any one of these causes can produce this effect, and they are failure modes. A failure mode is just a cause. It's a way to produce a particular effect. The effect in this case is a failure. So if you look at these items, I just listed them at the top, these column headings and item, potential, failure mode. If you laid out cause and effect, the goals of the organization have been impacted or could be impacted in some way, and it's because something happened, which they're calling actually an effect, and that's caused by failure modes, which they're again linked with ors, and the failure modes are caused by the causes. So the potential failure mode is here, and notice the failure mode is a cause of the effect, and it's also an effect of those causes. So a failure mode is a cause of the consequence it produces and an effect of whatever caused the failure mode. When you look at the potential effects of the failure mode, even though it says an effect of the failure mode, it still causes the impact of the company's goals. So you can't avoid this principle of cause and effect, that the effect is on the left and the cause is on the right, and then they link together, which creates this chain or this system. The severity is the impact of the goals, and then the possible cause of the failure over here. So you notice the FMEA lays it out in an order that fits the FMEA organization for severity, occurrence, and detection to multiply out RPN. But if you laid it out visually, it creates this map, and cause and effect would organize them this way. So we like the worksheet that's used for an FMEA, and a cause map tends to really complement that. The FMEA is a great structure to order the failure modes effects analysis, and a cause map, or what we call a cumulative cause map, really complements the FMEA because it visually lays out all the cause and effect relationships in the incident. So here are those headers again, and then here are those individual pieces. When you have action items, those are just solutions, as we talked about. The current controls are the symptom or indicator that we have an issue, and then the cause and effects are obviously scattered throughout, severity being the impact of goals. So it just tends to fit pretty cleanly that when you lay out a cause map, it's going to match up with your failure modes effects analysis because they're both based on cause and effect. You can identify specific solutions to control those, which is what you're doing on that worksheet. And then there are even effects that are indicators where you can trap errors if a failure mode happens or a cause occurs, that before it becomes this larger magnitude, if you had an indication or you were able to detect this, you can prevent that larger impact on the goals, which is called risk mitigation. Back to this original distinction between did and could, is that anything that did happen, all the causes are going to be linked with ands because you'll have evidence to validate that. Anytime you are missing evidence, those are the or relationships. It could be this or this, which is just how people speak right now. So the probability of something in the past occurring is 100%. That's why you only have the impact of the goals. There's just consequence. When you talk about what could happen, that's why probability and consequence fit in so well with the FMEA, because there's a likelihood of occurrence and there's a magnitude. There's the severity piece. So risk is fundamentally probability times consequence, and then within the FMEA they add in the detection point or the detection element, saying the more difficult it is to detect, the higher the risk, because it could be unknown or it could go unseen. So risk is expanded to probability, consequence, and detection are the elements. On this simple slide, it shows that you can investigate the Titanic from April 14th, 1912. Why did it happen? All the causes are ands, except where you're missing evidence. That's why the question marks are on there. You could take the information from the Titanic and talk about how a ship could sink, which lays out with multiple failure modes. And this is where the FMEA, built in rows and columns, provides a very good structure. And a cumulative map is a great way to organize that. So we just say it's another way to sort the information. Instead of rows and columns in a spreadsheet, you can lay the cause and effect relationships out visually, and we would say both work well. So companies that are very strong in FMEA continue to use the FMEA worksheets, and they build a map to complement that. One of the points I made in the webinar was if you put the FMEA in a binder on the table and you put the map up on the wall and bring 8 people in the room, people will naturally walk to the map. It's just a way to communicate detail a little bit clearer. But the FMEA is what could happen, and the root cause analysis is what did happen. And so the simple distinction between what could happen versus what did happen is an important part of any investigation. It explains this distinction between FMEA and root cause analysis. What you can do with the cause mapping method is you can investigate individual incidents on the date that they've occurred, so two different incidents a couple years apart, but maybe part of the same system at work, and you put both of those sets of cause and effect relationships on one map. We'd call it a cumulative map because it's a collection of what we know. There's another incident that occurred, and we add that, and another incident, and we add that, and you end up with this sum of information. Those are really the failure modes. There are different ways these four incidents have occurred, and we collect it on this cumulative map. We refer to it as a cumulative map or a reliability map because it becomes the collection of here's everything we know on what could go poorly. This information can be kept in one Excel file, so the Excel worksheets make it very easy to organize this. You can keep your FMEA and your cause maps in the one file to collect that history, but the key is just being able to start with one incident and dissect it thoroughly. The benefits here is root cause analysis and failure modes effects analysis are both about solving problems. That's the whole point. How do we solve this problem, prevent this negative impact to our goals? It happens to be when you build these cumulative maps, they're very effective troubleshooting guides. They are great for training new people. When new people arrive saying, here's what we know, here's what we do to prevent this from occurring, it's very similar to reliability-centered maintenance in terms of identifying actions. Business continuity, when experienced people leave an organization, they have a lot of knowledge in their head. How do we take what people have learned over the past 4 or 5 incidents and collect it so that we can keep it? And that's that continuity piece that a lot of knowledge ends up leaving the organization. If we could capture those details, and the map tends to be an effective way to capture what people call organizational knowledge. You can collect history on certain systems or pieces of equipment or within your business work processes to collect all in one spot. It's also a very effective way to share lessons learned and also best practices. So these cumulative maps, besides being a way to organize your FMEA, it connects RCA and FMEA together, but also a very useful guide in terms of capturing information that's valuable to your business. There's a simple graphic that shows how, if you do a root cause analysis, it ends up helping feed an FMEA, which you've noticed the people that have dealt with problems in your organization are the ones that also are available and should be available to help you do an FMEA because they know all the things that could happen. They've been through things that did actually happen, and that's how they can even discuss what failure modes could be. The information from the FMEA ends up feeding the way people actually troubleshoot and work individual incidents. So they really build on each other, and they complement very well. The idea is, how do we create a learning organization? If somebody's ability improves over time, his experienced individual then leaves and the new employee starts, and we have to relearn this. This is in Brian Joyner's book, Fourth Generation Management, this eyelash learning curve. How do you build on that to where you can maybe not start off right from where the experienced person left, but you at least build on what they know? And that's that concept of a learning organization, what best practices and cumulative knowledge and organizational knowledge are about. Once you have the cause and effect piece down and really the basics of the cause mapping method, then it makes sense when you investigate something that has already happened and you want to prevent it from occurring. It's a problem that's already occurred, and it's a negative issue. That's what root cause analysis typically is. You can look at negative things that have not happened yet and take a much more proactive approach. This is where the FMEA fits in, or the process hazard analysis, or the hazard and operability analysis, or risk management. It hasn't happened, but it could in the future, and we want to prevent it. Focusing on the cause and effect principle also allows you to say, well, what if we had something that occurred, but it was very positive? In the webinar I mentioned, Flight 1549 was a good success because the plane went down, but there were 0 fatalities. That you can do a root cause analysis. It's on our website at thinkreliability.com under RCA examples on the menu on the left. It lists some case studies, and Flight 1549 is one of the root cause success analyses that are listed in that website. Positive results were achieved, and we want to duplicate it again. We want to duplicate it in the future. Here is an incident that has not happened yet, but we want to produce these results. So the example I used, if someone's training for a marathon, they know the date that they're going to run the marathon and the time that they'd like to run that marathon in, and then they work backwards to identify all the things required to produce that result. So there is a future view, and there is a past view, and there are things that are negative and things that are positive. So the cause and effect principle doesn't change whether you're talking about the past or the future, or something that's negative, something that's positive. It's just most people focus on root cause analysis because it's investigating that negative problem, and failure modes effects analysis is preventing that negative thing from occurring. But you can apply the same cause and effect approach in any four of these options within this matrix. They're just different applications. So RCA, in simple summary, is what did happen. FMEA is what could happen. Both tools are based on cause and effect, and they're both about improving process. It's always about reliability. Mapping information improves the way people communicate, and the mapping the information creates this valuable record to the organization of here's a lot of knowledge about specific issue or issues that we've collected in one spot. So it changes the way people communicate in the organization.